Hello all, welcome to OneMedicine. Today we will be discussing about a very important physiological event, that is the cardiac cycle. So let's begin. Now before we start, we must understand what do you mean by a cardiac cycle. It's nothing but the event occurring inside the cardiac muscle between two consecutive heartbeats. Now what type of changes are those? Volume and the pressure changes. Before we proceed, you must understand a very important concept over here, that there are two types of activities which are going in the cardiac muscle, that is the electrical activity and the mechanical activity. Now the electrical activity comes first, which provides the stimulus leading to the mechanical activity of the heart. So whenever you will compare the ECG with the actual contraction in the heart, you will always see a small lag, because the electrical activity arrives first and the mechanical activity follows it. The mechanical activities occurring inside the heart are basically systole and diastole. So diastole means the relaxation phase of the heart and systole refers to the contraction period of the cardiac muscle. Now why is relaxation so important? Relaxation is important for the filling of the cardiac muscles, that is the ventricles. The blood filling actually occurs during the relaxation period. That's why diastole is very important. Systole, that is the contraction, leads to the pumping of blood to the different organs and tissues as per requirement. Now another concept over here is to understand is that the total duration of cardiac cycle is the inverse of heart rate. Okay, so why is this important? Because as the heart rate will increase, the cardiac cycle duration will shorten. Now since cardiac cycle comprises of two events, that is the systole as well as diastole, so there will be a fall in both of them. But as we know that diastole comprises the majority of cardiac cycle, so there will be a drastic reduction in the diastolic time period. It's important because the cardiac muscle won't get enough time to relax and there won't be proper ventricular filling. We will come to the actual cardiac cycle. So as you can see from this diagram, which has been taken from Guyton and Hall, there are several lines which are visible. So you can see here we are comparing all the events that is occurring inside the heart. That is, what are the changes? The ECG changes, the ventricular changes, pressure changes in the atria, ventricle and the aortic, and the phonocardiogram, that refers to the sounds which we hear. So we shall discuss and try to correlate them one by one. Let's start with the ECG. You can see over here the P wave, the QRS complex and the T wave. Now we all know that P wave refers to the atrial depolarization. Okay, QRS complex, during QRS complex the ventricles undergo depolarization. Please remember I am referring to them as depolarization and repolarization. Okay, and the T wave, during the T wave there will be ventricular repolarization. Please focus on this graph. We will divide this graph into two time periods, that is the diastole and the systole. The diastole starts as isovolumic relaxation. Diastole starts from here and it continues till the arrival of the P wave. Okay, this is the diastolic phase. This is the diastolic phase. It starts somewhere around the T wave and continues till the next P wave arrives. So what is happening during the diastole? We will understand that. First, focus at the ventricular volume. The ventricular volume as it is at its lowest during the diastole, that is the 50 ml. Okay, what is happening with the walls over here? You can see that over here the aortic walls have closed. Okay, and the AV walls are already closed. Please remember at the beginning of diastole both aortic and AV walls are closed. So there is a relaxation phase, isovolumic relaxation phase. Why? Because both the walls are closed, so there is no volume exchange, but the heart muscle is relaxing. So it is called as isovolumic relaxation. When this isovolumic, due to this isovolumic relaxation, the ventricular pressure will drop, right? The ventricular pressure will drop. As you can see on the top in this red line, the ventricular pressure during the isovolumic relaxation phase, you can see a steep fall in the ventricular pressure, right? So this fall will lead to opening of the AV walls, right? Opening of the AV walls. Now what will this lead to? This will lead to a sudden gush of blood from the atria to the ventricles. Please remember that when the ventricles were undergoing repolarization, atria was getting filled with blood, right? So as soon as the AV valves open, there will be a rush of blood from the atria to the ventricles. This is called as the rapid inflow, okay? Rapid inflow. So the volume in the ventricles, as you can see, the volume in the ventricles begins to rise. As we proceed further, the flow will slow down. This is known as diastasis, okay? The flow of the blood from the atria to ventricle will slow down. This is called as the diastasis phase, okay? You can see there is a rise in the ventricular volume, okay? This rapid flow and diastasis leads to 80% of the filling of ventricular volume, okay? The ventricles are filled by almost to the 80% of its limit during this phase, okay, during this diastolic phase. Now what will happen? Please let's concentrate over here to the ventricle pressure. As you can see, since there is passive inflow of the blood into the ventricles, and the ventricles are not presently undergoing any kind of contraction, so there is no pressure rise, the ventricular pressure remains constant, okay? The ventricular pressure remains constant. The atria will show some pressure, okay, a little bit higher than the ventricles because it has blood, so definitely it will be at a higher pressure gradient than the ventricles. Next, what happens? Now the P wave has come, okay? Now the P wave has come, so it will lead to atrial depolarization, as a result of which we will see atrial contraction. This depolarization will lead to atrial contraction, okay? Atrial contraction. As a result of which, what will happen? You can see there is a steep increase in atrial pressure. There is a steep rise in the atrial pressure, and it will lead to the rest of the 20% filling of the ventricles. Right, now please remember, now the systole phase has started. Now the systole phase has begun. So this will lead to the filling of the rest of the 20% of the ventricles. Now the ventricles has reached its maximum capacity, that is to say 130 ml. Ventricles have now reached its maximum capacity, and the pressure inside the ventricles have also started to increase because the amount of blood, it is now fully filled with blood. Due to the increased in pressure gradient in the ventricles, it will lead to the closure of AV valves. Here the AV valves will close, okay? Here the AV valves will close. So as soon as the AV valves close, now please remember, AV valves have closed and the aortic valves are closed. So now what happens? QRS complex will come, which will lead to the ventricular depolarization, okay? The QRS complex will lead to the ventricular depolarization, which will lead to ventricular contraction. Now please remember, since both the valves are closed right now presently, the AV valves have closed and the aortic valves are already closed. So we have the next phase of isovolumic contraction will occur now, okay? Isovolumic contraction will occur. Now why is this isovolumic contraction important? Because we have to overcome the pressure inside the aorta so that the blood can flow from ventricles to aorta. The minimum pressure inside the aorta falls to the level of 80 mmHg, okay? Now the ventricles should overcome this pressure. So by contracting isovolumically, they develop a steep increase in the pressure gradient. As soon as it overcomes the aortic pressure, instantly the aortic valve will open, okay? Over here the aortic valve will open, because of which there will be gush of blood from the ventricles to the aorta, okay? But remember, ventricles are still at a higher pressure because the blood flow has just started and the ventricle is still contracting. So it will reach a maximum pressure of 120 mmHg, and simultaneously the pressure inside the aorta will also keep on increasing, okay? So once it reaches the maximum pressure, and once the aorta overcomes the pressure of the ventricle, you will see a fall in the ventricular pressure, okay? You will see a fall in the ventricular pressure, and also there is a steep fall in, you can see over here, the steep fall in ventricular volume. So now what will happen? As the ventricular pressure will drop, the aortic valve will close. The aortic valve will close over here, okay? The aortic valve will close over here. right? You will ask, why is the pressure falling in the aorta? Because the blood is getting redistributed from here to the different tissues and organs, right? So there is a fall in the aortic pressure also, and the incoming blood has also stopped, so there will be a fall in the aortic pressure. As you can see, the pressure inside the ventricles will fall to its almost zero. It doesn't become entirely zero, but it falls almost equal to the zero. Okay, now let's focus upon aortic pressure and atrial pressure. Here you will see two types of incisura or notches. Okay, here are two notches. What is this notch due to? So please understand, when the valves close, say for example the aortic valve has closed. Now the blood is flowing with high velocity inside the aorta. So as soon as the valves close, there is a backflow of the blood. Okay, there is a backflow of blood which leads to the bulging of the aortic valve inside the ventricles, leading to a small notch inside, small increase over here, that is called as the aortic pressure. Same goes for atrial pressure. You can see the pressure falling, but there is a small notch because there is a bulge of the valve, AV valves, that is the tricuspid and the mitral valves, which leads to the small notches. Okay, now we all know the sounds that are heard during the cardiac cycle are basically due to the valve closure. Okay, it is basically due to the valve closure. It is not because of the opening of the valves. Why? Because it's a very soft process, right? So it does not produce too much sound. The flow of the closure of the valves is a sudden process, so it produces sound, which is known as the first heart sound and the second heart sound. Okay, now here we will try to understand one very important thing, that in both the cases, that is the S1 as well as S2, there is valve closure. But why are the sounds so different? Okay, why is S2 so different in its pitch and its duration from as compared to the S1? So please understand over here that the AV valves are bigger in comparison to the aortic valves. So the flow of the blood across the aortic valve is of very high intensity, and this closure is also very sudden as compared to AV valves. It's not, the closure of aortic valve is not as smooth as, and also the AV valves are supported by chordae tendineae, which you will not find in the aortic valves. That's why the second sound, that is the closure of aortic valves, produces a stronger sound. Okay, let's move on to the next few important terminologies related to the cardiac cycle. So first is the end diastolic volume. As the name suggests, it is the amount of blood present in each ventricle at the end of the diastole. Okay, post diastole, how much blood fills each ventricle is referred to as end diastolic volume. Now what is end systolic volume? End systolic volume is the amount of blood which is left in the ventricles post contraction. Okay, after the contraction or the systolic phase is over, how much blood is left into the ventricles is referred to as end systolic volume. At the beginning of diastole also, the ventricular volume was around 50 ml, right? It never comes down to the zero. Okay, so there will be always 40 to 50 ml of blood left in the ventricles after the contraction. Which brings us to next terminology, that is the stroke output. It is nothing but with each stroke or with each cardiac cycle, how much blood is pumped by the ventricles into the blood vessel. Here we are majorly focusing upon the left ventricles. So we are talking about the blood pumped by left ventricles into the aorta, refers to as the stroke output. This is a very important term clinically, ejection fraction. Now ejection fraction is actually nothing but the ratio of stroke volume by end diastolic volume, where stroke volume refers to the amount of blood which is pumped out by the ventricles divided by the amount of blood which the ventricles receive. Okay. Ejection fraction is a very important term clinically because it is used to assess the systolic or the contraction capability of the heart. It actually gives a proper measure of the proper functioning of heart. Okay, you will see it in the further tests that ejection fraction is a very important factor to determine the heart's functioning. Okay, so that brings us to the end of this cardiac cycle. I hope I was able to clarify some of your doubts. See you next time.